Okay, so today what we are going to do is we are going to learn our final form, our final equation for writing linear equations, and that is point slope form. And today is okay, point slope form. So before we get started with point slope form, I want to review all the things that we've already learned so far in this unit. So the first thing is slope. And slope is represented as rise over run. It is represented as delta y over delta x. It is represented as y, oh, I don't know why I wrote a big 2. Sorry. y2 minus y1 over x2 minus x1 equals m. Okay, these are the, I don't know, I guess I'll box them, the 3 ways that we can represent slope. Everyone following that so far? That should feel review-like, okay? Then the next thing we have after we have slope is we have slope-intercept form. So slope-intercept form. And really quickly, I just want to go back up here to slope. This here is the only one of these 3 representations that's a formula. Okay, so putting delta y over delta x, that's very similar to telling me rise over run. If you're asked to show work or you're asked for the slope formula, this here, which I wrote it backwards, but that part doesn't matter, could be m equals y2 minus y1 over x2 minus x1. This is the formula. Okay, so slope-intercept form. That is y equals mx plus b. My m is my slope. My b is my y-intercept. We could also look at the y-intercept as 0, comma b. Okay, if I was plotting this on a graph, that would be the coordinate, the ordered pair. So that is slope-intercept form. Then we look at standard form. And that is that ax plus by equals c, standard form. So at this point in time, the main thing we are doing for standard form is we are using it in order to identify our intercepts in order to graph. So if you recall, this is going to be used for intercepts. So if I have the x-intercept, that would be x, comma 0. If I have the y-intercept, that would be 0, comma y. And we substitute in here like the 0 for x because it's in the place of x, and then you solve. Okay, so this is for graphing intercepts. That's when we would be using that. Any questions about any of this? This is all review. This is what we've been working on for what feels like the entire school year at this point, right? Like this we've been doing a lot of. So then my last form is called point slope form. And a point slope form looks like this. Y minus y1 is equal to m times x minus x1. So this should look like something we kind of already know about, meaning we know what m represents. M is our slope, and we know what x and y are because they come from an ordered pair. So just to recall, m equals slope, and this would be x1, y1 in an ordered pair. So I'll go over in a moment what we do with this information, but this is the form. Okay, and then last thing I want to point out, oh, I can't get it all on the screen. That's okay though, kind of there. Okay, the last thing I want to point out is that slope-intercept form is our default form. Default form means everything should be in slope-intercept form unless it's specified otherwise. Okay, so even if I start in standard form, even if I start in point slope form, most of those are going to be asking us either something specific or asking us to convert to slope-intercept form. If I'm reading a word problem, I'm going to always try to convert into slope-intercept form as my final answer. So that's something to remember. We do have a big test coming up in about a week and a half. And so I want to remind you, everything on this page needs to be memorized. This is everything that you need to memorize that you're going to need to know, not just for this class, but going forward to Algebra 1. Okay, so 3 of these you already know. It's just this last one that we need to start to get comfortable with. And I have to tell you all, you've already been doing this, just not as formal. Okay, so hopefully it will feel familiar when we go over it in a moment. Okay, so point slope form, again, is y minus y1 is equal to m times x minus x1. And then my m is slope, and my ordered pair is x1, y1. So we use this formula when we are given information about points on a graph, but we are not given the equation of the line. Okay, so this here, point slope form, is used, I guess I'll write it up here, use to get the equation of a line. And the equation of the line is the y equals mx plus b. Okay, so we use this in order to get to y equals mx plus b. And again, you've already kind of been doing this, so hopefully this feels familiar. I'm going to start with example 1. Okay, example 1 is a point 2, 5, and then my slope, which is 4. So what we're going to do is we are going to substitute these items into, I sound like I'm like shopping items, these numbers into the form, the equation. So I have y minus y1 equals m times x minus x1. Remember, I always write the formula. Now I'm going to substitute. Y minus, when I substitute, I need to put into parentheses to identify that I substituted. So my y1 in this ordered pair would be 5 equals my m is 4 times x minus, and my x1 is 2. Okay, so the parentheses just indicate where I substituted in. These other parentheses were there all along. Now, you always look into doing your parentheses first. So I look inside. I cannot simplify this any further because they're not like terms. So now I'm going to have to distribute. So I rewrite y minus 5, because I didn't use any of this yet, is equal to, I'm distributing this 4. So 4 times x makes 4x, and 4 times, this is a negative 2, that makes negative 8. And then, in order to get to y equals mx plus b, I need y to be by itself. I need to isolate y. So I need to move this negative 5 to the other side. In order to do that, I'm going to use the inverse operation. So I'm going to add 5, and I'm going to add 5. So now I have y equals 4x, negative 8 plus 5 makes negative 3. And there you have it. And then in order to check that it's correct, so this would be a check, I'm going to take this equation, y equals 4x minus 3, and I'm going to substitute the point 2, 5 in to make sure that it holds true. So my y here is 5, so I would have 5 equals 4, substitute 2, minus 3. 5 equals 4 times 2 is 8 minus 3. 5 equals 5. Yep, that's true. And that's how you get to the equation of the line in slope-intercept form. So we're going to do one more example together. This is example 2. And this time we're given 2 points, negative 3, comma 1, and negative 2, comma negative 1. So the first thing I'm going to have to do is I'm going to have to solve for slope, because I can't do anything unless I have my slope. So I have m equals y2 minus y1 over x2 minus x1. M equals, my y2 is negative 1 minus my y1, which is 1, over x2, which is negative 2, minus x1, which is negative 3. And I substituted that negative 3 into parentheses so I don't get confused about my negative sign, because there's a subtraction and a negative sign, so I want to be able to keep those separate so I can pay attention to them. So now I have m equals negative 1 minus 1 is the same thing as negative 1 plus negative 1. So that makes negative 2 over negative 2 minus negative 3. So this is negative 2 plus 3, which makes 1. So I have that m equals negative 2. Now I'm going to do my point slope form. So over here I have y minus y1 equals m times x minus x1. So what I'm going to do is I'm going to pick one of these 2 points, and I'm going to work through to get to slope-intercept form, and then I'm going to do it a second time with the other point to verify they both end up being the same slope-intercept form. So let's start with negative 3, 1. So I have y minus y1 is 1 is equal to negative 2 times x minus negative 3. Y minus 1 equals distributing negative 2x minus, this makes 6. isolating y, +1, +1. So y equals -2x minus 5. Okay. Now I'm going to do the same thing with my second point. So I have y minus y1 equals m times x minus x1. And then here I have y minus -1 is equal to -2 times x minus -2. So there's lots of minus negatives happening. So I'm going to rewrite this again, simplifying out those minus negatives just so I can keep track of what's happening. So I have y plus 1 equals -2 times x plus 2. So now I've simplified some of the minus negatives in order to be able to see the problem a little bit clearer. I'm going to distribute this -2. So I have y plus 1 equals -2x minus 4. I'm going to subtract 1, subtract 1. Y equals -2x minus 5. And those both are the same slope-intercept form equation. So I know I've done it correctly. So there you have it. Now, I'm going to show you very quickly what we've been doing to show you how it's similar. Okay. So let's say I have the 2, 5 and m equals 4. We just did this problem. So what we've been doing prior to knowing this formula is we've been writing y equals mx plus b. And then from here, we substituted 4. So I have y equals 4x plus b. And then I took 2, 5, and I substituted it into this in order to find b. So I would have written 5 equals 4 times 2 plus b. This is 5 equals 8 plus b. Minus 8 minus 8, -3 is equal to b. So now that I got my b and I have my 4, then I wrote back and I wrote y equals mx plus b, y equals 4x minus 3. And then that's how I came up with the slope-intercept form. Doing it this way is very, very similar to what we were doing in point slope form. Okay. So you've been doing this. The difference is that this form here is a little bit more of the proper process to getting to the equation of a line y equals mx plus b. Okay, so there you have it.